Hi everyone, in this video we are looking at section 4.4, Simplifying Radicals, and we're taking a look at example 6c. We've been told that we have to simplify and state the restrictions. And of course, as you can see, we're doing some addition and multiplication, and we're dealing with radicands that are variables. So let's take a closer look and see what the restrictions must be for 6c. As you can see, we have 4 different radical expressions. In each case, we're taking the square root. And I hope you also notice that our variables, or our radicands, are variables, and each of those variables are written to a power which happens to be even. So we have y to the power of 4, x to the power of 6, and again that pattern repeats. So in each case, the powers are even. So you should recall this little rule over here, that when you take the square root of an even power, your restriction is really just that x, or whatever variable you're dealing with, must belong to the set of real numbers. So it can be a positive or a negative. It can be 0. It just has to be a real number. So we are simply going to write that x must belong to the set of real numbers. And of course, we also have y, so we must state a restriction for y, that y must also belong to the set of real numbers. And so that's it for your restriction. Now we can go ahead and actually do some calculation and do some simplification. So when you're taking the square root on your radicand's a variable to a power, consider how you can rewrite it so that we can express it as a pair. So just think about it. Remember when we say take the square root, for example, of a number like 9. We know that that can be written as the square root of 3 times 3, and then we know that when we take that square root, it's just 3, right? So we just know it's one of those 2 factors, that pair of factors that make the original 9. Similarly, when we're going to take the square root of x to the 6, we could rewrite that as x to the power of 3 times x to the power of 3. Recall your rules for exponents. When you multiply, you add the exponents. So 3 plus 3, of course, would be 6. So we haven't changed anything except the way that it's written. Similarly, we would have 2 times the square root of, well, it would be y squared times y squared. And then we would have subtract the square root of, well, x to the 6 could be written as x cubed times x cubed plus 4 times the square root of, we could write y to the power of 4 as y squared times y squared. Okay, great. Now it's going to be much easier because now we just need to take the factor, just one of these factors out of this pair of factors that it's inside the square root. So that would be 5, and it would be x cubed. Now we've taken the square root of x to the 6. Plus 2 times, well, we're just going to take one of these, so it would be y squared. Subtract, well, it would just be one of these, which is x to the power of 3, plus 4, and taking one of those would be y squared. So now we've taken each of these square roots. Now let's see if we have any like terms so that we can simplify this even further. Notice that we have 5 times x to the power of 3 minus x to the power of 3. And we also have 2 times y squared plus 4 times y squared. So we can add the corresponding like terms. So in this case, we would have 5 minus 1, right? 5 minus 1 times x cubed. And we would have 2 plus 4, so 2 plus 4 times y squared. In our final line, we would write 4x cubed plus 6y squared, and that is our final answer.